Morning, guys. Today we are back with another problem. In this problem, what we are basically doing is we are being brought over with a new problem statement, which typically shows the path with the minimum effort. And in this problem statement, what you can understand is that suppose you are like the problem statement goes like this. Suppose you are a hiker preparing for an upcoming hike, and you are given heights. Heights is a two-dimensional array, right? And a 2D array of sizes rows and columns, with heights rows and columns represent the height of the cell. You are situated in the top left cell. So currently you are at the starting position of the cell of the top left cell, and we are hoping to travel to the bottom right cell. Means the leftmost, rightmost bottom cell, right? So we can move either up, down, left or right. Matlab, we can move to all directions. Okay, up and down, left and right means all directions. And you wish to find the route with the minimum effort. A route with the effort is the maximum absolute difference in heights between two consecutive cells of the route. So here will be some rows and columns as input. The size of the row and column will be given as input, as you can see in the function minimum heights, and then we have to find. So before solving this problem can be solved in 2 minutes if we know the understanding of the priority queue and the understanding of the Dijkstra's algorithm. So before knowing Dijkstra's algorithm, what you need to basically understand is that algorithm is basically used for finding whenever what comes in your mind when you first hear this thing, Dijkstra's algorithm or the part with the minimum effort. Then Dijkstra's algorithm is something which comes in your mind for the first time. So whenever we are doing and solving something like this, so what you have to understand is Dijkstra's algorithm is used for binary trees, weighted graphs and all those things, for graphs, basically for weighted graphs. But whenever we are doing it for a path with two-dimensional arrays, so we will use the concept of priority queue, which is somewhat similar to the Dijkstra's algorithm, and this concept will be taken forward with the concept of maximum heap as well. So let's understand the problem over here. So yeah, so basically you can see is let me present this. Yeah. So yeah, so if my screen is presenting, what you can see is initially we will be given a path 1, 2, 3. So for this, what I can write over here is I can write just ignore our things, okay? Just ignore. Yeah. So here I can write over here is rows equals to 3. So this is our input. Okay. Similarly, we will also do the columns for the columns input. So for the columns input, I can write over here as columns equals to 3. This is also our input, right? So just understand that what are the values which are given in the question. So if you see in the value and the matrix which is given is 1, 2, 2, 3, 8, 2 and 5, 3, 5. So just clearly understand the values are given in the question is in the matrix is say for example, let's make a 3 cos 3 matrix, right? So it will be like this 3. So yeah, just ignore this. Yeah. So this is a 3 cross 3 matrix, and in this matrix what we are doing next is we are going to put the values. So the values are 1, 2, 2, and the values are 3, 8, 2. The values are 3, 8, 2, and 5, 3, 5. 5, 3, 5. So what basically you can do is, what basically you can understand from this particular matrix is that this is the given matrix. Okay, so I can write given matrix. So this is a two-dimensional matrix. Okay, so now let's understand the possible paths. Okay, the possible paths, like the way you can traverse through this matrix. So suppose you are at this position, okay, which is say 0, 1, 2. I'm just naming the position 0, 1, 2. So suppose you are at the position here, the given position, like the starting position. So from there, from the starting position, say suppose here, you can either move over here, you can move over here, you can move over here, or you can move over here. So but in this case, in the starting position, you know that you can move either bottom or the right side. Okay, you can move either bottom or the right side. So let's consider this particular sequence where let's consider the minimum path sequence. So say for example, we are moving from 1, 2, 2, 2, 5. 5. Okay, so let's calculate the efforts which our path is taking. So if you see if I take this particular path, the efforts over here is 1, over here is the efforts I'm taking is 0, and over here is the efforts is 3. So let's make it, this is one combination. Say for example, we are taking another path. So suppose we have taken already, this path is being already taken, right? We've already taken this path. So we want to take another path, or we want to explore another path. So for example, we are exploring this path. So in order to explore this path, what we can see is we are moving 1, we are moving 3, we are moving to 8, we are moving to 2, we are moving to say 2, and then we are moving to 5. So the difference, let's calculate the difference. So we were talking about this path, the path of 1, 3, 8, 2, and 5. So in this particular path, what we can see is there's a difference between there's a difference. So the difference we can calculate over here is the minimum difference is 2. From 3 and 8, the difference is the effort taken is between 3 and 8, the effort taken is 5. Between 8 and 2, the effort taken is 6. And the effort between 2 and 5, the effort between 2 and 5 is again 3. So over here, the minimum effort over here, you can see the minimum effort is over here is 2. Okay, and in this case, what you can see, the minimum effort is 1, 0, 0. The minimum effort is 0. And let's explore this particular path. So there can be multiple paths, right? So let's explore the third part, which is 1, 3, 5, 3, 5. So say for example, the path is 1, 3, 5, 3, 5. So while exploring the path 1, 3, 5, 3, 5, you can see there is a constant minimum effort of 2. So this is the most ideal path. So I can say it as most ideal path. So this becomes our most ideal path. So we have to particularly find this path, which is our most ideal path. Okay, so this path is the last path which I discussed, is this particular path. So let's now come back to the understanding of how the path with minimum effort works with the help of Dijikra's algorithm and a priority queue. So let's say, for example, what I can write over here is a priority queue. So I can say path with minimum effort. Okay, so in path with minimum effort, I will be using PQ as priority queue. So before making a priority queue, let's draw the initial matrix, right? So the initial matrix, let's draw the elements of the initial matrix. So the initial matrix are 1, 2, and 2, and 3, 8, 2, 3, 8, 2, and the next elements are 5, 3, 5. So in this initial matrix, what basically you can see, I will just mention the rows and columns index. So I will mention over here 0, 1, and 2 as the index of rows and column, 0, 1, and 2 as the index of rows and column. Now what I'm going to do is I'm going to measure which one is my source. The source is obviously 0, source is 0, 0 is the source for the start. Our goal, if somebody tells you what is the goal of solving this particular problem, so our goal is to reach from 1 to 5, kind of like a dungeon problem, but in dungeon problem we use a 2D like a dynamic programming approach, but with different constraints. But this is minimum effort. So whenever there is a minimum effort, you have to understand that why we are using Dijikra's algorithm with priority queue over here and not like any other algorithms like BFS and DFS. Although like BFS and DFS are given in the topic tags of this problem, but you can obviously use the priority queue with the minimum path effort. Okay, so like this from here to here you have to reach. I've already shown you this particular path 1, 3, 5, 3, 5. So this is the shortest path with a minimum effort. Okay, so source part is this. I can write the destination part, which is 2, 2. I can write the destination over here as destination. So from 2, 2 to from this to this. Okay, so now let's make another matrix. Initially, that is known as the distance matrix. So over here I can write it over here as, say, the distance matrix, and I'm going to write the distance matrix over here. So initially, the first element of this particular matrix will be the source matrix is 0, and the rest of the elements should be infinite because the distance can be infinitely long. So yeah, that's how you make distance matrix. So in this particular distance matrix, you can see I've made a distance matrix over here. Next, what we are going to do is we are going to make a priority queue stack. So in a priority queue stacks is like a big rectangular stack, like any other stacks. Okay, like any other stacks, and we are going to put the values over here. We are going to fill the values, and lastly, we are going to find the path with the minimum effort. So for what are the constraints? So the constraint is, for a path to be considered as the minimum effort, we have to take it as the path with the maximum of all difference. So path with minimum effort is a path with maximum of all differences. Okay, so now I'm going to quickly fill the path over here. Okay, I'm going to quickly check each and every path over here and how we are moving. So let's start from the starting point, which is 0, 0, right? So from the starting point, I can either move to the right or I can move to the down. Okay. So if I move to the right, first let's check me this condition. If I move to the right, what would be my difference? So from the starting point 0, 0, this is our first iteration. Okay. From 0, 0, I'm trying to move to 0, 1. Okay. And I'm also moving bottom, which is 1, 0. So the difference I'm getting in this particular iteration, the difference D is equals to 1 minus 3. So absolute difference of the element present inside these two coordinates is 1 minus 3. So what I can write over here is 1 minus 3 is equals to 2. Okay, since I have to take the absolute value, I will just put an absolute over here. And if I check from 1 to 2, from here to here, the difference will be 1. So obviously, when I can see there is two differences I have obtained. So which difference I have to do? Check. I have to check the difference, which is which is obviously the maximum of all difference, right? So initially over here in the priority queue, how we are filling the priority queue stack. So the coordinates will be first is difference, then is rows, and then is columns. Okay. So the first is 0, 0, 0, as the difference we encountered is 0, 0, 0. Whenever we in the starting point, we have to take it as 0, 0, 0. And the next we can see it as 1, 0, 1. Why 1, 0, 1? Because 1 is our difference and 0, 1 is the coordinate. Similarly, the next we have seen is 2, 1, 0. So why 2, 1, 0? Because we have seen the difference is 2 while moving from there to 1, 0. So whenever we have reached the particular, we have crossed the particular path, so what we are going to do in the distance matrix, we are going to just pop this element infinity and give its original value. So over here, the original value becomes 1 now, since the difference is 1. Over here, the difference becomes from 0 to infinity, so from 1 to 3, so the difference is 2. Okay, so over here it is 2. Now let's go for the next iteration. Okay, so the next iteration is also very important iteration. So in the next iteration, what we can see is we are moving from 0, 1 to a direction 0, 2. Okay, we are moving from 0, 1 to 0, 2. Now let's consider the difference. So from 0, 1 to 0, 2. So 0, 1, okay, to 0, 2. We can see the difference is we are moving from 2 to 2. So the 2 minus 2 difference is nothing but D equals to 0. But should we take this D equals to 0? Should we take this D equals to 0? No, we can't take this, because before this we have also obtained another difference, which is 1 already over here in the same path. Over here in the same path, you can see while moving from 0, 1, we have already obtained D equals to 1. So I will write over here, since previous difference is 1, which is greater than 0. So in the stack, I can't consider this as the minimum difference. Okay, so I will still write it over here as 1, and the coordinates it's 1, 0, and 2. Okay, now let me move to another coordinates. Okay, so just a second. Yeah, so this time when I'm moving to another coordinates, now I have to again pop this element and give its index, right? So I'm giving its index as 1. Okay, because the difference, this is the updated difference, which is in the rough calculation of our distance matrix. So now we are moving from, say for example, we have moved all these ways. Now we are moving from 2 to 8, right? We are moving from 2 to 8. So what is the difference we can get? Okay, so I will just quickly write over here as the next iteration as we are moving from 0, 1 to 1, 1. So whenever we are moving from 0, 1 to 1, 1, the difference is 6. How is the difference 6? Because 0, 1 to 1, 1, the difference is 8 minus 2 is 6. So I will write it over here. As the difference is 6, right? So this time the difference becomes 6. So once the difference becomes 6 in my stack element, what I'm going to put 6, 1, 1. Okay. Now let's come to another iteration. So which is 5. Okay. So what for moving particular this direction, say for example we are moving from 3 to 6, 5 and 3. Okay, so from 3 to 6, what is from 3 to 5, what will be the minimum difference? So 3 minus 5 is 2. Okay, so I will write it over here as 2. Okay, and again from 8 to 3, what I can write it over here as from 3 to 8. Say for example we are at a coordinate 0 and 1 and we are moving to 1 and 1. So again in this particular case we are seeing there is a coordinate possible 5 minus 8 minus 3, which is 5, and initially we already got 6 in this particular coordinate. So but in this particular case we are going to take the shortest or the smallest coordinate. So this 6 will be removed and it becomes 5. And in this particular case, what I can see is 5 and 3, so this will become 2. Okay, so in this particular case we are at the final, this is the final position, right? This is our final position or the destination position. So in the destination position, what we can see is 2 and 5. So whenever we are moving in a direction from here to here, the difference is 5 minus 2. So I can omit this and write as 3. But also in this case, when I am moving from here to here, the difference obtained is 5 minus 3, which is 2. So obviously 2 is smaller than 3, so we will take 2 as the final difference over here. Let's take this one. So whenever we're moving from 2 to 2, the difference can be 0, right? The 2 to 2, the difference is 0, because from here to here, the difference is 0, obviously, right? From here to here, the difference is also 0. So I can write it over here as 0, but no, I can't write it over here as 0, because I have already encountered in a similar coordinate the difference as 1, because you can see max difference was encountered earlier as 1. So this is our final difference. Okay, now I'm just going to quickly fill the coordinates as per the heap priority sort. So the coordinates after 6 will be like 1, 2 and 2, and it is 3, 2 and 2. Next we can see is at 2, 1 and 0, 2, 1 and 0. Next is 5, 1, comma 1. So all the second digits of this particular priority stack is referring the coordinates, and the first digit is referring the difference. So you have to be focused with the first digit. So next comes the 2, 2, 0, and finally at the top we get 2, 2, 1. So from what we can conclude from this particular problem, that what we are getting actually, so we can easily conclude over here, I can conclude over here that in the last or end, we are reaching this particular value, right? We are reaching this particular value, which is 5 present at 2, 2. So at 2, 2, distance becomes 2, okay, at 2, 2. So which is seen at the top of the stack. It is seen at the top of the stack. So this is the end and this is the start. So you can see these data structures are made by scientists over like say decades ago, but still they are very much into use, and this helps us in solving many real life problems as well. Okay, so now we are going to develop the code for this particular thing. So I will just quickly solve the code for this particular problem. So yeah, over here what you can see is now we are going to solve this particular problem. So you can see we have made a class per path. Okay, the minimum path, int minimum effort is there. So in minimum efforts, what I'm going to do is in static in minimum efforts, I'm going to pass to the array, say efforts equals to new int rows and columns. Once rows and columns are passed, I'm going to traverse through the matrix using this efforts, and I'm going to write over here arrays dot fill row comma integer dot max underscore value. Okay, so why we are using row comma integer dot max? We are basically initializing all elements of the efforts array to the maximum value. We are initializing all elements of the efforts array to the maximum value. Now we are going to quickly add a priority queue over here. Okay, so the for loop is done over here, so we can quickly add the priority queue. So priority queuing, say of the type, because the elements which we are doing again over here is the integer type. So if you have taken part in coding competitions or higher coding competitions like CodeChef, LeetCode and all those platforms, you will see like they will not even give you an integer priority queue. They might even give a dictionary, they might even give a string priority queue, and things just get complicated with a data type event. So be very clear whatever you are doing. The concept should be very strong, why you are taking particular algorithm and why not any other algorithm. So one day I'm thinking of making a small chart on the time complexities of different algorithms and which algorithm should be used in which type of questions. So such as a cheat sheet for you guys, so that you can easily do this. So now PQ is the object of the priority queue. So offer new int. So what is this doing? It is adding the starting cell to the priority queue, effort, row and column. So I've already told you what is effort. Effort is nothing but the difference. So if you have seen this particular thing, you can see over here 3 parameters are passed: effort, row and column, and in the stack also I've passed 3 parameters: difference, row and column. So difference is nothing but the efforts. So why, just don't get confused whenever I'm taking something out of the box. Just don't get confused that why I'm taking this, why this time can be something else as well, right? So like this is the pq.offer, showing the offer. Now we are going to do is we are going to check the define the possible movement directions: up, down, right and left. Okay, so I'm just quickly take this as this. These are the directions, okay, possible movement directions: up and down, right and left, all these things, because initially I've told you the directions I have taken in a directions matrix which is initially there. So in this direction now we are going to continue until priority queue is empty. So what does that mean? There's a list, there's a loop condition until priority queue is empty, means there's no element left to be checked. Okay, so what you can, so I can write it over here as while we can check until pq is empty. Okay, in this while loop what you can do is I'm going to take a current pointer, right? Current array, int current array equals to pq dot poll. So pq dot poll. So what does pq dot poll is doing in this particular thing? Extract effort, row and column of the correct cell. So int effort equals to current of 0, int row equals to current of 1, and int column equals to current of 2. Okay, so current of current of 2. So I've taken the rows, column and extracted them. Next, in this while loop only, I'm going to check if the current cell is the destination cell, which is the bottom right cell. So how will I understand? So I will just write it over: if the row equals to rows minus 1, row equals to rows minus 1. I've taken rows over here, which is the length. So do not get confused why I'm taking rows minus 1. I know I don't understand why I'm taking rows and why not n minus 1. So nothing to be worried. Rows is nothing but the n, or which is the number of rows. That's why we are taking is rows minus 1. Okay, and now we are going to take the column is equals to columns minus 1, which is also the highest possible number of columns. So think like that way. So you see, when you do all this like things, when you see and explore all these things, you will understand why these variables are, what things they are using and other stuffs. So in the if condition is done, when the if condition is done, what I can do is I can explore the neighboring cells. So I've never put a comment over here, but I will put, because it's important. So explore the neighboring cells. So in the exploration of the neighboring cells, I'm going to traverse through the loop like this for int direction is directions, which is pointing to the 2-dimensional directions array which I've created. So over here we are going to calculate new row and column for the neighboring cell. So for neighboring cell there will be a new row and column which is shown in the matrix over there. So what you can see is int new row is row plus direction of the first index, and similarly int new column equals to column plus direction of the first index. So once the rows and columns are being done, what you can do is we can check if new row and column are within grid boundaries. If new row and column are within grid boundaries. So I can just take it over here, can paste it over here, saying if the new row greater than equals to 0, yes, the new row has to be greater than equals to 0. The new row's boundations has to be lesser than the maximum boundation. Similarly for the column. Okay, so I'm not going to explain all this baby stuffs, but now I'm going to just calculate the new effort required to move to a neighboring cell. So you can see for a new effort, what we can do is you can just write int new effort equals to math.max. As I have already told, I have to take the maximum value and the maximum absolute difference. So over here math.max, I'm just passing effort comma math.abs, and over here I'm going to pass the heights new row, and over here new column minus heights of row and column, which is the original one, row and column, which is the original one. So I will just quickly check the number of boxes I've completed. Yeah, so over here math.abs box is also done, and rows and column is also done. So new effort is being calculated over here. Okay, now I'm going to check if new effort is less than previously recorded effort. Yeah, this is an important condition. If new effort is less than efforts of. So efforts of new row and new column. So once the if condition is done, what I can do is in this if condition, once the new rows, we have to update the efforts array with new efforts. So what I can do is update the effort array with new efforts. Update the effort array with new efforts. Finally, we have to add neighboring cells to the priority queue for further exploration. So what you can see is we are going to add the neighboring cells of the priority queue for further explorations. We are closing the if statement. We are closing the if statement. We are closing another if statement. Okay. We are closing another if statement. So wait, I'm just lost. So here, so this is the for loop. So total how many ifs are there? So one if is for this. Okay. This is the second if. This is the second if. The third if is obviously the third one is the for loop. Yeah, done. And this one is the main if condition, I guess so. So I have to just what this if. So there is a in directions, and then this one is basically signifying the while loop. Okay, the while loop is being completed. So after the while loop is done, what I'm going to do is return -1. This is the most obvious thing. If no path is found, okay, and finally close the class. So we are going to submit the code. So it was a exciting problem, and we have successfully completed this particular problem. We're looking forward to explore more problems, more hard problems, and more difficult problems. Thank you so much. Keep watching.